This is just another picture of what that looks like. So here's the scan. You can see the scan shows where the hole is, then you insert it. But why is that important? Well, if I don't have a surgeon or a medical doctor right there, but I have the technology, then a surgeon or a doctor from someplace else through the telecommunications can actually do this work. And so it was the first time a semi-autonomous function was demonstrated using the internet. So that was NEMO 12. NEMO 9, which is an earlier one, we used some of the Zeus end effectors, which is right here, and we also manipulated them. So not only could you do surgical procedures, you could also use it for rock sampling. These just happen to be off the floor of the ocean, Gulf of Mexico. And this is just Dr. Broderick, where the facility is. So then we said, okay, you can do it underwater. What about doing it wirelessly where there's no wires? I mean, I guess that's redundant, but this is in the middle of nowhere, extreme environment. Turns out this is where they made MASH and Little House on the Prairie, out in north of Los Angeles. So here's this bird. It's not a bird, it's an airplane, a little model airplane. And Yoast is 7 feet tall, so you can kind of judge the size of it. It weighs about 10 pounds. You throw them in the air, and it provides bandwidth. They wouldn't tell us how much bandwidth, but we thought it was about 1 to 1.5 megabytes of communication and downlink and uplink. So why is that important? Well, if we have the robot, this is the Raven, it's on one side of the field, over here, and the controllers, this is Dr. Broderick, controlling these end effectors on the other side of the field. So we had to separate about 150, 200 feet. We had to take generators out there, gas, and it was about 105 degrees. And we were able to actually manipulate the robot. And of course we had to use wireless routers, and it was a mess, but nevertheless we got to work after the third day of going back and forth to FYE buying various technologies. But the idea was to go back and forth between 1 and 2 with the instruments. And then we would take and suture, we'd throw a couple of stitches. Now, we didn't get to part of the stitches because, guess what, everything was redundant. Like in NASA, of course, some things are triply redundant. We had 2 arms, we had 2 controllers, we had a bunch of laptop computers, 2 generators, all these people. We had 1 motherboard, and it crashed, and so we weren't able to do the work. So that's a lesson there. And you can see how they told us you can use these to actually, from 1,000, 2,000 feet, read license plates. And there's about 4,000 of these little mini airplanes being used in Afghanistan and Iraq. And they're used by 18, 19, 20-year-old Marines, so they're not difficult to use. I don't mean anything by that, but it just means that it's not rocket science. So surgery and flight, the same thing happened this morning. It takes a little longer for this slide to here we go, oops. So we have in this example here, now we're going to say, well, are we ever going to be able to do robotic surgery during flight, not necessarily during space flight, but during air flight from Balad, or from Baghdad, excuse me, to Landstuhl, or from someplace in Afghanistan. So we took this modified robot, put it on the DC-9, which is this airplane here. It's affectionately called the Vomit Comet. And Heidi Pepper Stephenson was sitting here, and the controllers for the Da Vinci, remember you have to sit there and you have to put your head in this device. Now you have the device here where they're out in front of you, and they have acceleration compensation. I mentioned this to the students the other day. They had no idea what I was talking about, so I'll try it again. Do you remember the Saturday Night Live skit with Sammy Davis Jr.? He was driving up in Lincoln Continental, and he was going to perform a circumcision. Does anybody remember this one? Okay, there was a car commercial back in the 79, 80, 84 time period. I think it was the Lincoln Town Car. You could put a glass of wine, and it wouldn't fall over, because no matter how much of the road they went over. Well, they did a spoof on Saturday Night Live. The same thing here. It dampens that compensation. So in a moving vehicle on a bumpy road, you could actually do surgery and not affect the tissue. That's important if you're going to fly in an airplane, especially flying in an airplane that hits turbulence and is flying out of the theater, war theater. And by the way, they use the same technology on the treadmill. So when somebody's running on a treadmill, you don't see the space station wings going like this. That would be important too. Just some different examples of how the lab was set up in the facility. You can see people fly. The Vomit Comet flies in parabolic flight. So when you fly like that, when you come up to the crest, the plane begins to drop, and as it drops, you float for about 30 seconds or so. We also looked at surgical simulation in this environment. We had a bunch of astronauts and surgeons help us, and of course, there are 2 manuscripts published in different journals. Talk a little bit about that. Again, some more training, surgical training. You can see the upper right-hand picture is how do you train somebody who is perhaps going to be doing a procedure? What kind of training do they need to have when they do the procedure? And then more importantly, how do they handle fluids, body fluids and blood and things like that? Some of the overall challenges, I think the most important one is scalability. Can you take the current environment, the current surgical devices, and change them enough that you could actually do surgery remotely, say from here to a Katrina site, or from here to Haiti, for instance, or some other kind of situation. Let's see, there's anything, all important stuff, but I just wanted to make sure we get through the last couple. Well, the rest of the presentation is classified. This is just in the last 2 or 3 slides. This is called Octobot. It's the size of a ballpoint pen. And the idea was to be able to insert this in a needle. You can see the bevel of the needle. And that would actually go down into the tissue and be able to have light, suction, instruments, graspers, an ultrasound, and a cautery device. This is the operating room of the future. It's interesting. This comes from DOD. It's probably about 4 or 5 years old now. And they had flat panel monitors 4 or 5 years ago. I'm not sure why they still use these old CRT machines. And they still have lights hanging from the ceiling. They've got LED lights now. The entire ceiling is full of LED lights, and so as you walk, the lighting of the room, the operating room changes. So where your concentration of people is where it's brightest. You don't need lights over there if there's nothing over there. Most doctors, most surgeons who see this, they really don't like this picture because they're afraid of dressing like that in the future. And of course, if you think about using a system like the Da Vinci, you'd be able to go to a tool crib and grab the instruments that you need. This happens to be a picture outside the Mars thing up in Devon Island. And so if you look out the window, you might see this one day. Thank you very much. Oh, we can do that. Yeah.
All right. Thank you. Thank you, Mr. Doaran. If you have any questions for him, I'm going to ask, he'll be available. He's outside, and only because you only have an hour for lunch right now.